Welcome! The mountains we've been building during the last clip have started producing large amounts of sediments. Where will they end up? Places where large thickness of sediments are accumulated are called sedimentary basins. These accumulations can be very thick, up to 10 or 12 kilometers, and can form in very different contexts. How can we make space for so much sediments? What are the controlling processes? Sedimentary basins are systems with two components. On the one side, the processes which control the amount of accommodation space available. On the other, the processes which control the amount and type of sediments produced and eventually deposited into the basin. Note that in most sedimentary basins, creation of accommodation space and sediment production are related to different processes which take place in very different, often unrelated regions. Always keep them separated from each other. We will focus now on subsidence. In next modules, we will look at sediment production and deposition. In a previous clip, we've defined the notion of accommodation space as the space where sediments can be deposited and preserved. The most intuitive accommodation space is the water column between the sea level and the sea floor. In the absence of subsidence, the maximum thickness of sediments which can be deposited corresponds to the accommodation space. As sedimentary succession can be orders of magnitude thicker than the accommodation space available each moment, we need processes creating new accommodation space during time. We've called this phenomenon subsidence. Building on Archimedes' principle, we've seen that subsidence can be generated by thinning the crust, which is the light part of the system, and is enhanced by the thickening of the mantle, which is characterized by its high density. Changing thicknesses of the lithospheric component is equivalent to applying an extra load to a plate. Note that the load can be positive if the lithosphere becomes heavier or negative if the lithosphere becomes lighter. The magnitude and width of the accommodation space depends not only on the weight of the load applied, but also on how strong the loaded plate is. This is an effect we did not look to until now. If the loaded plate is very soft, then the new load and the underlying segment will simply sink, and subsidence will be limited to the area where the new load is applied. The resulting sedimentary basin will be very narrow and confined to the same domain. If, however, the substratum of the new load is very strong, then no subsidence whatsoever will take place, and the topography will correspond to the height of the load itself. No sedimentary basin is created. Reality is often between these situations. The load will push downward part of the plate, but because this has a strength, then also adjacent domain will subside, creating new accommodation space, and therefore sedimentary basins. The first type of sedimentary basin we will look at are extensional basins. Here, the accommodation space is created by the extension of the lithosphere. Extensional basins begin forming continental rifts. If extension continues, then the lithosphere becomes so thin that it will break, and eventually leading to the formation of a passive continental margin. Vertical movements in a sedimentary basin can be documented using a subsidence curve, which describes the vertical position of a point during rifting. The blue curve in the slide is a typical subsidence curve in an extensional setting. Before the onset of rifting, not much happens, no faults, and subsidence is limited to non-existent. When extension starts, normal faults will develop, which open extensional basins and cause crustal thinning. Both concur in creating subsidence. Following rifting, we enter the post-rift stage, when subsidence is controlled by lithospheric cooling. We have seen that the faster the rift, the higher the thermal anomaly, and the stronger the post-rift thermal subsidence will be. Very important sedimentary basins also develop in domains with shortening. During shortening, rocks are piled up and form therefore an extra load applied to the underlying lithosphere, which is gray in the picture. If the lithospheric plate has a finer strength, then it will flex downward, create an accommodation space, which might then be filled with sediments, probably derived from the eroding adjacent mountain belt. This is the four-deep basin. In the picture, you see the main elements of four-deep basins: the lode, the basin itself, and the loaded plate. The basin which developed has a triangular shape, thickening towards the mountain and pinching out away from it. Here, some final take-home messages. Sedimentary basins are thick accumulation of sediments. A tectonic process is needed to initiate sedimentary basins. Sediment loading does amplify subsidence, but it is unable to keep the machine going. The type and amount of sediments deposited in the basin are conditioned by processing taking place in the source area. Sedimentary basins host resources, and their responsible management is a key to social development.